Okay, let's take a look at one more thing here. Here I started with our plot of the x squared and the sine and the two different colors and line styles. And there's another way to do that where you don't put them both in the same line, but you could do them separately. No particular reason to do that in this case. But, you know, here I've just copied this line down here and eliminated the parts that had to do with the sine. I left the extra curly braces around there. It doesn't matter because it was easier to do. And it's still a set of one item, so there's no confusion there. Same thing over here. There's an extra set of braces there which don't really matter. So what should be here should be the x squared plot. What should be here should be the sine plot. There they are. Now, if we wanted to combine them after we had separate plots, here's the thing. If you put a semicolon at the end of this, it suppresses the output. So you don't see the graph, and I'm going to suppress the output here with a semicolon. I'm going to rename these. I'm going to rename this one as plot 1. I usually just call it P1. P1 equals that. So the variable P1 contains this plot, and don't forget to execute that. You can tell it's not executed because there's no input line here. Okay, now it's executed. You can ignore the little helpful things that pop up there, and I'm going to call this one P2 equals enter. And now there's this thing called the show command. I want to show both of those on the same graph. P1 comma P2. Enter. Okay, there you go. And I could put a plot range command on this, and I probably should because I can't see much of my sine graph. It looks like the first one overrode the range of the first one, overrode that. So I'm going to see if I can put a plot range command in there. And I often use the one that allows you to specify x and y because that just allows you more flexibility. But for quickness here, I'm going to make it y goes from -3 to 3. Okay, there. Now I can see the sine. Okay, now obviously that's not necessary when you can do the whole thing in one line with a set of functions. But if that's all you were going to do, that is plot the two functions, you just use the first plot command up there that had both of them in the same set. But what if you wanted to plot x squared plus y squared equals 4 on top of that? There you end up with the problem of having to plot the top half and the bottom half separately. That would put 4 functions in your plot command, and they wouldn't come together quite right, just like happens with your graphing calculator when you do that. This is where Mathematica steps away from the graphing calculator in that it can plot implicit functions. And if we pull our palette up here, there it is. The command for that is another plot command. There's several different plot commands. We're going to use a couple of them here. So here's a plot command for contour plot. And that's another one you probably wouldn't think about. It's an implicit plot, but they use contour plot for that. So if you wanted to know how to do an implicit plot in Mathematica, you would search for implicit plot Mathematica in Google to get the keyword contour plot to get you started. And I don't have to look up help. I'm just going to plug in there's the syntax for it. It's a function. There's something about a function you need to know. Here's the domain. Here's the range required for a contour plot. And I've already gotten this one filled in. So here's the function x squared plus y squared equals 4. That's syntax. You got no choice. It's double equals when you're writing in an equation. X goes from -3 to 3. Y goes from -3 to 3. And let's see what that looks like. It's a circle. Okay, fine. I'm going to suppress that output. And I'm going to call this P3. And now I'm going to show, if I get this, I'm going to show all 3 of those. P1, P2, I'm actually, okay, comma, P3. I thought I ought to have little braces around those inside. Maybe not, because it works. Oh, but that doesn't work so well because it's distorted. There's a fix for that. If I change this plot range so that it has both x and y, the x goes from -3 to 3, comma, y goes from -3 to 3, and it's still stretched a little bit. That's the aspect ratio, and you'll learn where to find these things pretty quickly, but I think it's under Other, Aspect Ratio, Automatic. I don't know if that's going to do it or not. It did. Okay, so there's the, you might have to go help Aspect Ratio if that didn't work. I would have had to do that.